Hi everyone, myself Dr. Lakshmi Prasad, working as an associate professor in the Department of Data Science in Institute of Aeronautical Engineering, Hyderabad. In this video, I'm going to discuss about the overview on statistics and its type. So, statistics is nothing but a branch of science which is going to be deals with collection, presentation, analysis, and interpretation of data, and it provides a method for analyzing and accessing the significance of data. And this statistics enable the transformation of data into information so that can be served as the basis of decision making. So the statistics is a branch of science which is going to be deals with collection, presentation, analysis, and interpretation of data. So it provides the method for analyzing, accessing, and significance of data. So mainly this statistics serves as a basis for decision making. So when it comes to importance of statistics, so statistics presents the facts and figures in definite form, and it should also helps to condense the data, and it gives the idea about the shape, spread, and symmetry of the data, and should also facilitate the comparison, and it should also measures the relationship between two or more variables, and it should also helps in estimation and prediction. And the importance of statistics also formulate the testing hypothesis and also helpful in planning, controlling, and decision making. So, what is the definition of statistics? Is that the statistic is nothing but a branch of science, so which is going to be deals with collection, presentation, analysis, and interpretation of data. So, mainly, it provides the method for analyzing and assessing the significance of data, and should also enables the transformation of data into information so that can be solved as a division of making. So there are two main branches of statistics. So first one is the descriptive statistics, and second one is inferential statistics. So descriptive statistics means which is going to be organized, describes, and summarizes the characteristics of the data. So it should also includes the construction of graphs, tables, charts, and calculation of various numerical measures such as mean, median, standard deviation, percentage, etc. It does not involve in generalizing beyond the data at hand. So descriptive statistics mainly summarizes the characteristics of the data. So it includes construction of graphs, charts, tables, calculations of various measures such as mean, median, and then standard deviation, percentage, etc. as well. For example, I'm going to have a question like a batsman wants to find his batting average for past 12 months, and politicians want to know average number of votes received in past 3 years. So average daily temperature of the Pune. So when it comes to inferential statistics, so it mainly concerns in drawing the conclusions on predictions about the population from the analysis of random sample that is going to be drawn from the population. So it includes the methods like point estimation, interval estimation, and hypothesis testing. So it includes this point estimation and interval estimation and hypothesis testing. So these three are the methods that is going to be used in order to make the conclusions and predictions about the random sample. Suppose the question like the politician would like to estimate the pre-election polling techniques such as opinion polls and his chance in winning the upcoming election, and researcher wants to determine if the treatment A is better than treatment B. Population and sample. So population means an aggregate of objects or individuals under study. Sample is nothing but any part of population under the study. And suppose Example is that if we want to study the industrial development of city XYZ, so there are total 500 industries in the city. So all these industries constitute population. So if we randomly choose the 100 industries from the total of 500 industries, so these 100 industries will constitute a sample here. And population, so population is nothing but numerical value that's going to summarize the characteristics of the population under investigation. So the parametric values are typically unknown here, and the statistics are the numerical values that summarize the characteristics of the sample, which we use to estimate the parameter. Suppose if I'm going to have a population, so like this, so some part of this population will be treated as a sample here. So not only that, I can able to construct this one also a sample, and this one also a sample, and this one should also be a sample. And what is the data sampling here? So sampling is nothing but a statistical technique for obtaining the sample data, which is the representation of population, so that the inferences based on the sample hold true for the population as well. So why do we sampling? So when it is not possible to measure the every item in the population and the population is infinite, then when the results are needed urgently, and when the area of the study is wide, and when elements get destroyed under the investigation, so because of those following reasons, we have to conduct the sampling here. So what are the benefits of the sampling? So sampling reduces the processing time, and should also results can be obtained very quickly due to the time saved in data collection for the analysis, and should also reduces the expenses incurred in the collection of data and its analysis. So thus sampling should be economical. And due to reduced volume of work, so the data collection and analysis can be completed efficiently using well-trained staff and sophisticated machinery. The key concepts used in sampling, so members and elements of population, and then number sample size is nothing but the number of units in the sample. And sampling frame a list of the members or the elements of population. So if I'm going to consider a population, so these and all will be called as members or elements. And if I'm going to consider, so the elements which are present in this sample, and so totally if it is around some 10, that should be the sample size, and this thing should be treated as sampling frame. Types of sampling. So types of sampling, so there are the four different types of sampling. So first one is simple random sampling, stratified sampling, systematic sampling, and then cluster sampling. So simple sampling is the one very easy to implement, and stratified sampling is something different and overcome the disadvantages of simple random sampling. And systematic sampling is the one where you can able to select the samples in a systematic manner. And cluster sampling means where we're going to group the elements or the members into one cluster, which is going to have similar characteristics. So types of sampling we'll see. So simple random sampling. So simple random sampling is conducted so without replacement, because it is more convenient and should also give more precise results. Simple random sampling is effective if the population is homogeneous and population has no differentiated sections or classes. So example, in order to conduct the socio-economic survey of the particular village, we can randomly select a sample of families and find the per capita income of the village. Simple random sampling means, so here we're going to have a population. So in that we're going to select this random samples of this population, and this should be act as a inference to the population. Stratified random sampling. So in this one, the population is going to be divided into different non-overlap homogeneous groups. So what we call it as a strata here, and then a simple random sample of suitable size is selected from each of the stratum to form a sample here. So here, so the population what is there, so this one is going to be divided into different non-homogeneous elements. So this group what we called as a strata here, and then we have to apply the simple random sampling among this strata to form a sample here. And strata is going to be divided based on some criterion such as geographical location, or based on age, gender, religion, or income. So this is the example what I'm going to explain now. So that is, to estimate the annual income for family, we can divide the population onto homogeneous groups such as a family with an yearly income below 50,000 is one group, and in between 50,000 and 1 lakh is one group, and between 1 lakh to 1.5 lakh is one other group, and above 1.5. See here, this is the population we're having. So in this population, I'm going to divide the population into different segments. So where I'm going to take a sample of this one population, and similarly I'm going to consider the sample of this population. So entire thing should be considered as a one sample here. So each and everything should be called as this one as strata. So the sample of the strata 1, and this should be the sample of strata 2 like this. And next one is that systematic sampling. Here, this method involves the selection of elements from an ordered sampling frame. So in order to draw this systematic sample of size n, so the sampling units are going to be numbered from 1 to n, where n is the population size. So we have to calculate the sampling interval as k, that should be written as capital N, that should be sample size, population size by sampling size. Selected random numbers such that we're able to take from 1 to k, and thereafter again we have to select the kth element from j plus k, j plus 2k, and so on. So once the first unit is selected at random, it determines the entire sample. So systematic sample example is that, so we have a committee of n students, so that is going to be selected out of 60 students. So in order to draw the system sample of size n, so the students are going to be numbered with the roll numbers up to 60. So select the first random number from 1 to 10. Suppose it is 5. I'm going to consider as 2. And the difference of 2 I'm considering. So this should be the systematic random sampling. So 2, 4, 6, 8. See this example. So the population here is this, and from this population I'm going to select the 5th random sample of every series. So I'm going to get 5, 15, 25. So this and all will be treated as a systematic random. The next one is that cluster sampling. So this method is going to be used when the population is large and consists of several groups, and these groups what we called as the clusters here. So in this method, the cluster should be considered as the sampling unit, where you can able to select the simple random sample of clusters, and all observation in the selected clusters are to be included in the sample. So smaller the size of cluster, better will be the results. So for example, in the health service of state, So the state is divided into different villages, what we call it as a clusters. And simple random sample of the village should be selected first, and the information about the each individual is going to be selected. Village can be collected. So if I'm going to have a population like this, so in this population, I'm going to make a cluster of group of similar people. So this and all will be treated as a cluster 1, and this should be cluster 2, cluster 3, like this. So see the example. So this is the group of population I'm having. So from that population, I'm going to extract some of the sample of that cluster. So that should be considered as a sample here. And next one is the types of data and then sampling techniques. So normally this data will be of different types. So based on variables and based on constant. Again, this variable should be of the type qualitative and quantitative. So again, this quantitative should be divided into discrete and so what is this discrete and continuous data? We'll see one by one. So data is nothing but in any facts or observation, the information is going to be collected together for inference and analysis, which is going to be used as the basis for decision making. And variable means any characteristics whose changes its value. So example, height, weight, sex, martial status, and height color. So these variables can be treated as a qualitative and then quantitative. So mainly data is nothing but a fact or observation or information that is going to be selected. It serves as a basis for decision making. And variable means so any characteristics whose changes its value. And the variables can be classified into two types like qualitative and quantitative. So the first one is constant, is nothing but the characteristic who does not change its value or nature. Suppose the height of person after 25 years of age. Qualitative data, that means so it is a non-numerical data that can be arranged into categories. Uh, this data also called as a categorical data. So example, a gender of individual and nationality of the player and grade in the examination. Quantitative data, so it should be a numerical data that can be consists of counts and measurements. For example, so gender of individual, male and female. So this should be the category, right? So nationality of player. So Hindu, Muslim, Sikh, Christian, like this. And grades in examination like A plus, A, B, B plus. So all these are will be the categories here. So this and all will comes under qualitative data. So quantitative data means where have some counts and measurements. So weights of person, kgs, examinations in marks, and profit of the salesman $30. So this and all will be considered as a quantitative data. So what is quantitative data? So this quantitative data is further classified into two types like discrete and then continuous. So discrete means that it contains only the finite or countable number of values and these are usually whole numbers. So example, the population of the country, number of cases of certain disease and number of students in the class. Continuous means which takes all the possible values in certain range and thus have an infinite number of values. Then this value does not contain any gaps, breaks, and then jumps. Example, height of the person, feet, temperature at certain place, and agricultural production, 1 acre. So like this. So this and all will be the continuous data where the data should be changes with respect to time. So quantitative data, discrete and continuous. So discrete is going to consider only the finite and countable number of values, and continuous means which is going to be hold uh, all different possibility of values in certain range and does not have infinite number of values. So sales of measurements. So the variables can be classified based on its scales and measurement. So first one is Stephen SS. So introduce four types of scales of measurement. So first one is nominal, ordinal, interval, and ratio. So these are the four different categories of scales here. The first two scales of measurement comes under categorical variables. So that is nominal and ordinal. And later two should be comes under qualitative variables, what we call as interval and ratio scale. So these are the different scales. So what is this nominal scale? So nominal scale consists of two or more named categories in which the objects are going to be classified, and the data at this level can be ordered in a meaningful way. For example, the classification of individuals such as blood group, and then classification of individual using sex, caste, and nationality. So this and all will considered as a nominal scale. So ordinal scale means, so here this should be somewhat similar to nominal scale. So however the data at this level can be ordered in a meaningful way, but the difference between the data values can be either determined or it should be meaningless. So example, a group of individuals according to income such as poor, middle class and rich. The group of students according to grades in the examination such as fail, second class, first class distinction like this. So this and all will consider as a ordinal scale. And next one is that interval scale. So the data from the interval scale can be ranked order and has a sensible spacing of observation, such as differences between the measurements and meaningful. And interval scales lack the ability to calculate the ratio between the numbers on the scale, but there is no 0 point. So the temperature like Fahrenheit and centigrade Celsius scales. And ratio scale means the data on the ratio scale include all the features of individual scale. So in addition to the true 0 point, and therefore calculate indicate the ratio of difference between the two spaces on the measurement. So it is the best scale of measurement and is going to be used in most on all places. So example, monthly income, height in centimeters and weight in kg. So next one, collection of data. So the data is going to be classified based on the type of that. So primary data, that means they should be considered as original data. So collected by the individual investigator himself or herself for a specific purpose. And this type of data should be generally considered as first fresh and then collected to be first time. The data can be collected below the methods like observation method, interview method, survey method, and questionnaire method. Example, population census. The data can be collected by researcher is another project. Secondary data. So the data can be selected by someone else prior to and purpose other than the current project. And this is going to be processed and then finished data. And secondary data that is going to be reused, and it involves less cost, time, and effort. So example, already the data taken from office records, reports which are already selected by other agency, and data available on internet, and data from books and magazines. So there are the two types of data according to methods of collection. So first one is primary. So here this is the original data collected by the investigator and itself by itself, and some of the data collection methods will be observation, interview, survey, and then questioning. So where the population census and data collected by researcher for the result. So types of variables. So normal, just now what I said, that should be qualitative variables and quantitative variables. Qualitative means brand of PC, martial status, and hair color, and quantitative means so that should be discrete and continuous. So discrete means the countable number of portion, like number of children in family, so number of strokes in the group, whole and TV sets want. And continuous means the amount of tax paid and weight loss, weight of the student, and the yearly rainfall in Tampa. So data types should be of these two types, like discrete and continuous. So nominal means the assignment or a number of classification purpose for a categorical data. Ordinal means the ordinal data values provides a classification according to the order or magnitude. And interval means here the classification is done according to the continue with this interval equality and subdivision sensibility. And ratio scale means they should be the data within an absolute value of 0 with height and weight. So what are the statistics of this? So if I'm going to consider the kind of comparison distribution, two samples. For the comparison of two samples, I'm going to take chi-square test. So there should be, in case of normalization, what I'm going to consider is chi-square test or z-test, and Wilcoxon and Whitney text chi-square test. Suppose if I'm going to consider the group of two test groups, so one can able to take one sample that should be considered as sign test, and then one sample and then sign test again. So a comparison of values test of more than two variables, two groups that should be treated as independent variable, and what we kind of test we're going to perform is chi-square test, and then variance is the one. So there are four levels of measurement. So when the data can be classified into four levels. The four levels of measurement of the data indicates the calculation that can be done to summarize and presenting the data. And it should also determine the statistical test that should be performed here. Nominal means the observations of the quality variable that can be classified and counted. And ordinal means the data represented by the sets, labels, names, and therefore have relative values and they can be anchored and then ordered. And interval means it includes all the characteristics of the ordinal and additionally the difference between the value and the constant size. And ratio means that it is had all the characteristics of interval level, and additionally 0 point is missing, that the ratio between the two numbers is missing. So what are the different types of charts and statistics? So statistics is a method statistics is the method conducting a study about a particular topic, so by collecting, organizing, interpreting, and finally presenting the data. So the usage of statistics in a daily life is that where you can able to use the statistics in government agencies, science and medicine, psychology, education, and then companies. So the definition of bar graph. So bar graph is a chart that uses either horizontal or vertical bars to show the comparisons between the categories. Normally the bars are going to be classified into different tabs like a single bar, multiple bar, and stacked bar. So single bar means we are able to construct along the single parameter. So this is the one attribute, and these are the characteristics of an attribute. And multiple bar chart means, so here within a single attribution, I can able to construct different multiple bars. So if I'm going to consider the two characteristics of a variable, I'm going to go for multiple bar chart. And stacked bar chart means it is also a simple bar chart where we're able to divide these bars into different segments where each segment is going to be represent an equal bar, that means based on the percentage. So if you look at this, so the number of cars sold in a week, so I'm going to consider the colors of the car, and I'm going to consider number of cars sold on y-axis. So if I'm going to consider blue color car, the number of cars sold is 4. And next one is that silver color car and red color car, green color car, and then black color. So here it should be 5, 14, 6. So these are the different types of colors where you can able to show the different features. So what are the advantages of bar chart? So it is going to be show the data category in a frequency distribution and should be able to display this relative numbers or proportions of multiple categories, and should also summarize the data set in visual form, and should also estimate Q value at glance, and should also be easy to understand due to widespread in the business and the media. So some other disadvantages will be require additional explanation and be easily manipulated to yield false impressions and fail to relieve key assumptions, causes, effects, or patterns. So example, so I'm going to consider years and profit along the year. So it should, by seeing this graph, you can able to realize that the profit is every day go on increasing here. And next one is multiple bar chart. A multiple bar chart is going to be used to represent the distinct values for more than one item and that share the same category. So if I'm going to consider this, so here the number of exports and imports in the year, I want to mention it for that. So dollar is going to represent an import, and green is going to represent export. So if I'm going to represent more than one characteristic of the variable, then I can go for multiple bar. And when it comes to simple bar, so 1989, so what is the profit? 1990, what is the profit that is there? So based on that, I'm going to represent what is the profit, then profit 22, and what is the profit? 1981, 18, 1992, 25, 1993, 42. So what is multiple bar chart here? So multiple bar chart is going to be used to describe the distinct values for more than one item, and that is going to be shared the common category. So here yellow is the imports and green is the exports here. So based on the different multiple bar chart, we can able to differentiate and then we can able to easily compare the difference between them. Next one is subdivided bar graph. So what is subdivided bar graph? So subdivided bar graph chart is going to be used to describe the data in which the total magnitude is divided into two different components. So why these the subdata bar graph is used? So the subdata bar graph helps in the representing the total number of elements in the group. So what is subdivided bar graph? So this one is going to be used helpful in representing the total number of elements in the group. So the subdivided group also established in identifying the competitive useful. The subdivided bar graph also helpful in identifying and comparing the difference between the components. So let us consider. So A is the division, ABC is the division, and the number of boys in the division and number of girls in the division. So I'm going to add so the total number of boys and girls. So that should be obtained. And graphical presentation, that means a stack bar chart where the rectangle is going to be divided into different sections. That means so here. So this is the percentage of boys and girls in group section A, and this should be boys and girls in section B, and this should be the percentage of boys and girls in section C. So by seeing this graph, we can similarly identify. So the graph A should be the better one. So let us consider an example. So the expenses of the family, so A and B. So these are the expenses of family A and the expenses of family B, and this should be the total number of expenses. So if I'm going to construct a bar chart like stack bar chart, so I'm going to represent with respect to 100. So what is the percentage of green, red and blue? So here also same, red, red, green, 3 here. So what is the percentage here? So percentage, so that should be 1100, and here it should be 2800, it is 2200, and percentage in group 1700, it should be 2000. So like this I can easily compare the attributes also very easily when compared to food, clothing and then petrol. So if I'm going to consider group A, then the clothing is more when compared to B, and if I'm going to consider the clothing is also less when compared to the clothing in group B. And next one is pie chart. So what is this pie chart? So pie chart is also called as pie graph or a circle graph. So make use of sectors in the circle, and the angle of the sector is proportional to the frequency of the data. So the pie chart is the way of displaying the data when you want to show how something is going to be shared and divided. So the pie chart is also called as pie graph and circle graph. So where you can able to use sectors in the circle. So the pie chart is only the way for displaying the data when you want to show how much something is going to be shared and divided. So what is the equation for calculating the angle of the sector? So frequency of the data by total frequency into 360. So in a school there are 750 students in first year, 420 students in second year, and 630 students in third year. So they draw the circle graph to represent the number of students in this graph. So totally I'm going to calculate the total frequency of these students. So year-wise angle that should be, so first one is 750 by 100 and 1800 into 360. I'm going to get 150 degrees. In percentage it should be 150 by 360 into 100. That is 42 degrees. Similarly, and for calculating this angle to 420 divided by 1800 into 360, 84, in order to convert into percentage, that should be 23 and 35. So first 42, 23 and 35. So this is the percentage of students in different groups. So what are the advantages of this? So the size of a circle can be made proportional to the total quantity it represents, and this it also summarizes the large data set in visual form, and be visually simpler than other type of graphs, and should also permit the visual check of reasonableness and accuracy of the calculation. And mainly it requires the minimal additional explanation, and then we can easily understood due to widespread use in business and media. And what are the disadvantages of this? So it does not easily reveal the exact values, and many pie charts may be needed to show the changes over the time. And it should also fail to reveal the assumptions, causes, effects, and patterns. And they should be easily manipulated to yield a false impression as well. And next one, types of graphs in statistics. So in that one, first one is histogram. So histogram is nothing but the graphical representation and should be helpful in organize and display the data is more user-friendly format. So the uses of histogram is that so it helps in comparing the process within a specified limits, and it also summarizes the larger data, and then it assists in decision making. So example, so if I'm going to consider the class interval like 20 to 30, 30 to 40, 40 to 50, and 50 to 60, so the frequency of depends how much it is in between them, I'm going to mark it. So for that, I'm going to construct the histogram like this. So the only difference between histogram and bar graph is that, so I'm going to maintain the space in between each rectangle bars, but here I'm not going to maintain any graphs in space in between them. So if it is so this is the 15 in between the interval and range of 30 to 40, it should be 20, and in between 40 and 50, it should be 30 like this. So example, let us consider large data set. So I'm going to consider this data set in between the intervals. So 15 to 20, how many? 20 to 25. So the frequencies are going to be calculated here. So once the frequency is calculated, then we have to construct in between the intervals here how many it is. And next one is that frequency polygon. So this graph uses the lines that connect the points plotted for the frequencies at the midpoint of the classes. And these frequencies can be represented by height of the points. So in order to construct this frequency polygon, so find the midpoints of the each class and draw x and y axis and use midpoint for x values and frequencies as y values and plot the points. So connect the adjust point with the line segments and draw the line back to the x-axis and beginning and ending of the graph. So here this is the count or frequency what we called previously. So from this count I'm going to calculate the cumulative frequency. How to calculate this? So 0. So 0 plus 3, 3 and 3 plus 10, 13, 13 plus 53, 66, 66 plus 107, 173, 173, 147, 320 like. So this is the construction of frequency polygon. So how to construct this one means, so it should be joining the midpoint of all the lines actually. And this should be the histogram initially constructed. So how this frequency polygon is obtained means by joining the midpoint of each and every rectangle bar what is there. So once you dot it, then joining with a smooth curve or freehand line. So the straight line, joining all the dots, and after removing all these rectangles, then the curve line what is going to obtain that should be treated as the frequency polygon. And a view, so a view is the under kind of graph, so which is going to be representing the cumulative frequencies for the all the classes in the frequency distribution. So in order to construct the view, so first find the cumulative frequency of each class and then draw an x and y axis and label the axis and boundaries as well, and then plot the cumulative frequency at the upper class boundary and start with the first upper class boundary, connect the adjacent points with the line segment. So constructing statistical graphs, the general procedure will be that, so we have to draw and label the x and y axis and choose the suitable scale for frequencies and cumulative frequencies and label it on x and y axis and represent the class boundaries for the histogram or OGU at the midpoint of the frequency polygon x-axis. So plot these the points and then draw the bars and the lines. For example, if I'm going to have example like this, so this is the data weights of 20 people. So what I'm doing, so I'm going to be take it out into different groups. So for this, I'm going to construct the stem and leaf graph. So in stem, I'm going to consider 0, and stem 6, I'm going to consider 5, and stem 7, I'm going to consider 7, and stem 8, so these are these values, and stem 9, 0 to 8, and stem 10, 5. So in this one, what I'm going to do that is, uh, so in this 20, in these values, I'm going to consider the last digit as the leaf and first digit as the stem. So 5, for the 5, what are the leaves? 0. For 6, I'm going to have 5, and for 7 it should be 5. For 8, I'm going to have leaves 8, 5, 5, 6, 6, 7, 7, 8. So these are the values of it. Then put that as values in our data. We'll start with the tallies and then note down this frequencies. From the frequency, note down the cumulative frequency of that one. So once the cumulative frequency is done, then you have to draw the graph. So how this one is going to be constructed is, so take a construct a histogram first and join all the midpoints of the rectangle, then you can able to get it. And next one is a pictodiagram. So pictogram, what we call it as. And so instead of representing this pictogram, the frequency of the data, so instead of frequency, we're going to show the pictures here or symbols. So where this each and every symbol represents the units of the data. So here in this one, the cost is there, right? Each picture is going to represent 4 cars. So how many number of cars sold in 4 company means 1, 2, 3. So 3 means 3 into 4. So total 12 cars. So how many number of title cars sold means 1, 2, 3, 4. So 4 into 4, 16. So like this, we are going to be consider the pictogram. So pictogram represent the frequency of the data and the pictures or symbols. Each picture or symbol may represent one or more units of the data. Next, to follow the tables and show the number of computers sold by the company for the months January to March. And here the month February, January, February, March, the number of computers sold is this one. So how to construct this pictogram? So by taking the pictures, so number of computers sold. So suppose each computer represents 5 count. So the number of computers sold in January is 5 into 5, 25. Similarly, in January, February, 7, 7 into 5, 35. 4 into 5, 20. So like this, we are going to be represent the pictogram. So what are the advantages of this? So it should be easy to read and visual appealing. And disadvantage is that it should be very difficult to draw, and then icons must be of consistent size and best for only the 2 to 6 categories and very simplistic. So these are the disadvantages of this one. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.